Hey, what's up? Okay, this is chapter 3.1, question number 2 on page 112. Two boxes of books are stacked and placed on the floor of an elevator. The masses of the bottom and top boxes are 9.5 kilograms and 2.5 kilograms respectively. The normal force between the floor and the bottom box is 70 newtons. Determine the magnitude and direction of the elevator's acceleration. So what we're looking for is acceleration. Using force and mass, we know that F net equals ma. Therefore, just by rearranging the equation, acceleration equals F net divided by mass. Now, in order to find F net, we just have to add all the forces acting on our boxes. So, F net is equal to Fn plus mg, which is just our normal force, and then our force of gravity. So if Fn is equal to, if F net, is equal to Fn plus mg, we know that Fn is 70 newtons, and then what's happening here is that although the mass of the bottom box is 9.5, these are touching, so we just consider these all one mass. So 9.5 newtons and 9.5 kilograms and 2.5 kilograms makes 12 kilograms. So that's 12, and then kilograms times 9.8 meters per second squared. And that will give us an F net of, oh, this should not be a plus. This should be a minus, because force of gravity is in the downwards direction. So 70 minus 12 times 9.8, which is 117.6. I'm just going to skip writing that. That gives us a F net of negative 47.6 newtons. Now that we have this F net, and we know the mass, which is 12 kilograms, and remember that's considering both the boxes, we can find the acceleration. So where acceleration is equal to F net over m, we have negative 47.6 over 12, which is equal to negative 3.97 meters per second squared. This is negative, so basically what that means is that the acceleration is 3.97 meters per second squared down. So that's the magnitude and direction of the elevator's acceleration. Determine the force that the larger box exerts on the smaller box. So the question's asking about the force exerted on the smaller box. So the mass that we're going to concern ourselves with is the 2.5 kilograms. And then remember, in order to find the force that is exerted, we do mass times acceleration. But we know that the elevator is accelerating down, and we also know that there's the normal force acting up, the 9.8 newtons. Here it is. Our normal force is acting, and that's 9.8 times the mass. But now we also have this acceleration, which is going down. So what we have to do is we have to do F equals 2.5 times 9.8 minus, because this is down, minus 3.97 meters per second squared. And then if you were to multiply that, you get 9.8, so it's 5.83 times 2.5, 14.58 newtons. So the force that the larger box exerts on the smaller box, so from this box to this one, is 14.58 newtons.